Hello, welcome to the final video of a many-part video series on data manipulation and transformation using dplyr in R using our studio. So today we're just gonna finish up the summary exercise provided on the original literature. So there's a total of 8 questions, but I skipped 2 of them because I don't really understand what they're trying to ask or what I'm trying to do. So I also edit some of the questions so that it makes more sense for me and it demonstrates better how you can do with this algorithm. So don't be too shocked when you see there's some difference between the one over here and the one provided on the link that I provided down below as well, because I kind of have to credit the source regardless of what. So the first question is referring back to the list of useful mutate and filtering functions. Describe how each operation changes when you combine it with grouping. So in grouping for a summary, they actually separate the overall data frame into subcluster first before you summarize the total data frame. So I'm not going to try and do it over here, but I hope that you at home would actually try to I'll try to add another line of group by into the mutate and filtering function up above and see what happens. I would say that's the best way to understand how a certain sequence works. And for now, let's go to our second question over here. So which planes has the worst on time record? So if you don't know tail num, so tail number is the number that is located on an aircraft that is unique to the aircraft itself. So one aircraft will only have a certain tail number, something like MH370 or something like that. So the tail number is specific to the aircraft, and we know that this is the aircraft that is fly from one place to another, and it's just a unique identifier for aircraft basically. So we want to know which one has the worst on time record. So that is basically what we mean by arrival delay. So you can actually modify the code to calculate departure delay, same concept, but let's just do arrival delay over here for now. So the first thing, of course, is to filter out the cancelled flight, because those should not be counted in part of the systems. And we group by the tail number, which is the aircraft. And then we do a summarize. Remember, group by always almost followed by summarize, because they always goes together very well. Okay, so what we do is that we create another new column called mean arrival delay, which is calculated based on the mean of arrival delay with a remove, NA remove. Fairly straightforward, and we arrange it. So let's see what data do we get over here. So you can actually see that this tail number has the worst delay, but you also have only a single flight. So this delay only happened once, but it kind of have the worst. But this aircraft only fly to this airport once. Okay, so there are also some like with 6 different delay. There are also some with a little bit more, which is 41 delay. The thing is that usually when it's 1 or 2, we don't really want to calculate it as part of summary, because you can't just kill a person just because he has done something wrong in his life once. So you might want to give him a little bit more chance, at least for the aircraft flight response. So what we do is that we add one more rows over here, which is filtered the count that's less than 10. So anything, we only want to look at data when there's more than 10 flights per year. Okay, so we can look at here, this aircraft over here has a total of 13 flights and a mean delay of 66. So the one that's more concerning is having a 41 count, but an average delay of 1 hour. So if you are on this flight, you basically know that it's gonna be, you're gonna have a delay basically. Okay, so this is how you can actually just really fast and easy look at the thing that you want to look at using a combination of filter, group by, summarize, and arrange. Okay, so let's go to the third question. So what time of the day should you fly if you want to avoid all the delay as much as possible? So here we're gonna, instead of just using a table, we're also gonna import ggplot2. Okay, so what we do is that we group by the hour, because that's kind of the most detailed things we have in the data frame provided. We don't really want to group by second, otherwise every single thing will come up. Okay, so we want to know roughly the region of that. So that's why we group by the hour. And again, we filter out all the cancelled flight, and we summarize the delay as the departure delay, which is only include the calculation when the departure delay is more than 0. Because as with our data set, there are actually departure delay that is less than 0. So because they left early, so that's not really delays that we want to do. So you can also do the other way around if you want to know what time does the flight depart early. Okay, so then finally we port the data into a ggplot2 using a geom column function. So you can actually see from the data here, let's just minimize this, that everything around 5-6 o'clock has the lowest number of delay, while around 8 o'clock, 7, 8, 9 o'clock has like the really big number of delay. So if you want to fly, try to go in the morning and not on the evening after dinner, basically. So if we do not want to use a geom column, we can also use something called geom point range, which actually give us similar trend, but instead of just give us one number like column chart that we have just now, this one will also give you the spread of the delay. So as you can see, the result is somewhat similar, and it's around 7, 8, 9 o'clock which has the worst delay, and 5, 6, 7 has the least amount of delay. But also because at night we have a lot more flights compared to in the morning. So you might want to make a decision based on that, not just on the exact average value alone. Okay, so that's basically answer our question. You want to fly in the morning. So let's go to the fourth question. For each destination, compute the total minutes of delay. So in this case, fairly straightforward. We just group by the destination, filter the cancelled flight, and then summarize the total number of minutes. So you can see that if you want to go to ATL, the delay is really bad. If you want to go to A and C, the delay is very small. So you can also, let's just arrange based on the destination, shall we? So we can we should arrange based on total minutes. So we kind of want to know which one has the least delay. So LEX, no delay at all. PSP, very little number, and actually we can go to the back. So ORD, I have no idea where is this, Orlando or something. So that will be the worst number of places to fly to if you want to avoid delay, basically. Fairly straightforward question to answer. So I skip question 5, you guys can't answer. I look at the solution, I have no understanding of what they're trying to do. So let's look at our number 6 question. So looking at the destination, can you find flights that suspiciously fast and the flight that represent potential data entry errors? So which one is super fast and unlikely to make sense? Okay, so let's go to this one. So what we do is that, of course, we just group by destination, arrange by airtime, and then we arrange by airtime. So we can actually avoid this, but it's just kind of make things a little bit easier. Actually, I should change the order a little bit just to make things a little bit easier to see for certain people. Okay, so you can actually see here for this destination, these are the airtime that's suspiciously short. So flying to BDL, I have no idea where BDL is, but it's only 20 minutes. So yeah, it might be wrong. So because you see the scheduled departure time, arrival time is actually around 1 hour, but the air time is only 20 minutes. So it might be a data entry error, it might be something wrong with the sensors, we have no idea. Okay, so which flight were most delayed in the air? I have no understanding of what this means, and I don't know how to answer it. So if you know the answer, please put a comment down below. You can also find an actual solution in the GitHub page that I found and a few other websites that I have referred to. But I don't understand what the question is trying to ask for. I'm not really good in aircraft, obviously. Okay, let's move on to the last question. So find all destinations that flown by at least 2 carrier and use that information to rank carrier based on how many locations they travel to from. Okay, so here actually first thing we need to actually introduce is the new function called ndistinct. So what ndistinct is, it's actually a faster and more concise equivalent to length unique x. So it's just a way of count unique if you have actually worked with Excel before. So let's just actually create an example over here. So if x is a sample of 1 to 10, 500, so you don't know what that means, is that x is a vector with 500 elements, and they are randomly selected from 1 to 10. Okay, so if you do a ndistinct on x, you realize that it's only 10 because there's 10 unique element in x. That's basically the function of ndistinct and what they do. Okay, so let's go to our question. So we want to find, first of all, destination that were flown by at least 2 carrier. So we group by destination and we filtered based on ndistinct carrier plus 2. So in that case, what they do is that you will have group by, so individual destination. Every destination has a few carrier. So if there's only 1 carrier, throw it away. If it's more than 2 carrier, only that we include them into the further calculation. So now we'll only have data frame that has all the destination removed, that's only flown by 1 carrier. Okay, let's go to the third one. So the Actually, let's just run it so that we can have a look at. So instead of 336,000 rows, we now left with 300 rows, around 300 rows, because those that are only flown by one carrier, we don't care, we don't want it. And next one, we actually want to group this new data frame by the carrier and summarize the number of destination that we have. So we're using destination to cluster carrier, and then use carrier and cluster the destination again. So, and then lastly, we just arrange it based on the number of things that they have. So if you run the whole thing at once, you will realize that these are all the name of the carrier, and these are the distinct number of end. Okay, so Delta, I think DL is Delta, has 36 different locations. EV has a total of 36 locations. UA has 36 locations, and so on and so forth. So this is basically what they have. So I'm gonna take a little bit of risk over here. I'm gonna risk re-recording the whole thing again and try to do something else. So once we have this ready, we can actually find what is the 37 different number of location in DL. Okay, so shall we try that? So first of all, of course, we filter the carrier is equals to DL. Okay, then we try to, yeah, I think that's kind of it, isn't it? Let's just try it first. Okay, DL, do you need, yeah, sorry. Yeah, equals. Okay, so that's basically it. We have 48,000 rows. So now we need to see what? Now we need to see all the destination, right? So we summarize the unique destination that we have, and we should be fine. I'm not sure this is gonna work. Oh, okay. So these are not the, okay, I know already. So we need to group by destination, and then we summarize the destination. And we do an end distincts on the calculations. Yep, got it. So that's basically all the 36 different of them. So that's the 40 different of them. I'm sure there's something wrong with the some of the calculation over there. Why is there different calculations? So let's try again. So there's 37 of them there. Oh yeah, because this has a destination that is only by Delta alone. So that's basically, you know, some of the ugly coding exercise that I do on the back end that you don't see in front of the camera. Everything you see in front of the camera is me doing a lot of background troubleshooting and then come to the conclusion. So I think that will come to a close to this series. I hope that you learn something and enjoy. As always, all the script and all the files are linked in the video description below. I strongly encourage you to go there and copy paste onto your RStudio and try yourself at home. And if you have any problem, feel free to leave a comment down below and send me an email if you need to. For now, I don't know how to close this video. I'm just gonna say bye and happy coding stuff. And I'll slowly move away from the frame.